So for this video, we're going to talk about exponents and the order of operations. So I'm going to do just a very quick reminder of exponential notation. Then we're going to start talking very specifically about exponents that have negative bases. Then later on, we'll talk about order of operations. So right now, for topic one, we want exponents, or exponential notation with negative bases, okay? So we first have an expression of the form a to the n, where a is the base and n is the exponent, indicating how many times the base is used as a factor. That is exponential notation, okay? So let's look at something really, really super basic. Let's say that we had 2 to the fourth power. This is not 2 to the fourth being 2 times 4. This is 2 to the fourth being the base is 2, 4 is the exponent, and 4 tells us how many times the base is used as a factor, okay? So right here, this is the same as 2 times 2 times 2 times 2. So again, notice the base of 2 is used as a factor 4 times. So if we wanted to multiply this out, I would take 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So that's how you would evaluate exponential notation, where everything's just kind of positive, okay? Now, what we're going to talk about is very specifically when the base is a negative, okay? And there are two things that can happen. You can have a base that is negative inside parentheses, or you can have a base that is negative where the base is not inside parentheses. So consider it looking like this. We could have negative a in parentheses raised to the nth power. That would be a situation where we have a negative base inside parentheses. Or we could just have negative a to the nth power. The negative is not inside parentheses. And that's the big difference between how we're going to deal with this stuff right here. Okay? So first of all, for when you're dealing with a negative in parentheses, the negative sign is part of the base. Therefore, it is a repeated factor. So it is part of, I should say, part of the repeated factor, okay? And the exponent determines the sign on the final product. So we need to review a couple of things. When you're talking about multiplication, so multiplying signs, we have a couple of things that we need to remember. When you multiply the same sign, we get a positive product. When we multiply a pair of different signs, we get a negative product, okay? We've also in a previous video talked about what happens when you multiply a series of numbers that involve positives and negatives. So if you're multiplying a series of numbers, if you have an even number of negatives, the result ends up being positive because each pair of negatives become positive. And when you have an even number of negatives, every group, they're all going to pair up. So each negative has a pair, okay? When you have an odd number of negatives, you're going to have all of the negatives pair up and become positive, except you're going to have one leftover negative. And that one leftover negative is going to make the whole thing negative. So again, if you have an even number of negatives, all of those negatives pair up to become positive. But if you have an odd number of negative signs, you're always going to get a negative product because all of the negatives pair up except for one, and that one negative kind of makes the whole product negative. So that's what's going to be happening here when we have a negative base that is inside parentheses. So the negative sign is part of the base. That means it's part of the repeated factor, okay? In this case, the exponent determines the sign on the final product, and we're going to go right back to this stuff right here. Okay, if you have an even exponent, that tells us that when the negative base is raised to an even exponent, the result has to be positive, because if you have an even exponent and that negative is part of that repeated factor, that tells you you're going to have an even number of negatives. And each pair of negatives groups together, they just become positive. So when you have a negative base raised to an even exponent, the result is positive. Okay, and again, the reason is multiplying an even number of negative results in a positive product. So let's look at an example where we have a negative inside parentheses and an even exponent. So I like to use 2 because 2 is easy to work with. So we have negative 2 in parentheses to the fourth power. So that's the same as negative 2 multiplied by itself 4 times. Well, you can see here, this pair of negatives, they're going to group together to become positive. That just equals 4. This pair of negatives, they're going to group together to become positive, and that just equals 4. So really, at the end of the day, we have positive 4 times positive 4, which gives us that final product of positive 16. Okay? Now, let's talk about what happens if you have an odd exponent. Okay? So when a negative base is raised to an odd exponent or to an odd power, the result is going to be negative. And the reason for that is multiplying an odd number of negatives results in a negative product, because all of the negatives pair up except for that last one, and that one makes everything negative. So let's look at an example. So we have -2 in parentheses, so the negatives part of the repeated factor. We have that raised to the 5th power, 5 being odd. So you can see these two pairs, this pair of 2's, they come together. -2 times -2 is positive 4. This pair of 2's come together to become positive 4. But then you have this guy by himself. He has nothing to pair up with, so he's going to stay negative. So this ends up being 4 times 4, which is 16, times -2, which gives us -32. So here you can kind of see how that exponent really does tell us if we're going to have a positive or a negative product. Even exponents, every negative pairs up and becomes positive, positive product. Odd exponent, all of the negatives pair up except for one, and that one negative makes everything positive. Okay, so if you have a negative in parentheses, you can have a positive or a negative product. Okay, now let's talk about what happens when you have a negative that is not in parentheses. Okay, so without parentheses, we have an expression. Let me put it in red. I'm going to circle it so you can see it because it got kind of grouped together with stuff. So without parentheses, we have something like -a to the n power, no parentheses to be seen. And what's happening here, if I have -a to the n power, that is really just like -1 times a to the n power. So we're going to take positive a to the n, which is always going to be positive, and then essentially we multiply it by -1. So this is always going to be negative. So without parentheses, the product will always be negative because, again, it's just like taking -1 times whatever a to the n is. Okay? So it says the negative sign is not part of the base, which means it is treated as a separate factor. It's not a repeated factor. It's its own factor. Okay? And then it says the negative sign is applied after evaluating the exponent. So the result is always going to be negative. So let's look at a couple of examples. So the first example, we have -2 to the 3rd. The negative is not inside parentheses. So that tells me the negative is really like a -1 as its own factor. So I would start out by rewriting this as -1 times 2 to the 3rd power. Well, 2 to the 3rd power right here is just 2 times 2 times 2, which is +8. So this is really -1 times +8. Well, -1 times +8, a positive and a negative, that's where I get my -8 as my final product. So again, without parentheses, it's going to be negative no matter what. And you'll see an example here where we have an even exponent and we're still going to get a negative product. So the next example, we have -2 to the 4th power. Okay, we did an odd exponent prior. We got a negative product, but the exponent had nothing to do with the fact that this was negative. So let's show it again with the even exponent. So because the -2 is not inside parentheses, that negative is really treated as its own factor of -1. So I would automatically rewrite this as -1 times 2 to the 4th. So that -1 is its own separate factor. So I've got my 2 to the 4th right here. So I get -1 times 2 to the 4th. Well, 2 to the 4th is going to be positive. It's just 2 times 2, which is 4, times 2 again, which is 8, times 2 again, which is 16. So this is really -1 times 16. And when I multiply a positive and a negative, that's how I get my negative product. So if the negative is not inside parentheses, it does not matter if the exponent is even or odd. Your product is always going to be negative because that -1 is a separate factor. Okay, so keep that in mind. Let's look at some examples. All right, so example 1 here just says evaluate. So when we're told to evaluate, we just want to work it out into a single number. We're going to find the eventual final product. So the first example, part A, is -6, not inside parentheses, squared. Without parentheses, this negative right here is treated like its own factor of -1. So then that gives me -1 times 6 squared. 6 squared is just 6 times 6, which is 36. So this becomes -1 times 6 times 6. So it's going to be -1 times 36 or negative 36. So without parentheses, just really understand that that -1 or that negative, we treat it as its own separate factor of -1. You're always going to get a negative product. Okay? Now for part B, we have -5 to the third power. -5 is in parentheses, so that negative is part of the repeated factor. So this is the same as -5 times -5 times -5. Because my exponent is odd, I know the final answer is going to be negative something. Let me get rid of the 1. I don't know why I put the 1 there. It's going to be negative something. So let's look here. -5 times -5 is going to be positive 25. But then I still have this other factor of -5. So 25 times 5 is 125. But now we've got a positive times a negative. So here we get negative 125. Okay? Part C, we have -3 in parentheses to the fourth power. Because the negative is in parentheses, it is part of the base, which means it is part of that repeated factor. So this is -3 repeated as a factor 4 times. And then just let's prove it to ourselves. We know that because we have an even exponent, this final answer is going to be positive, but let's really prove it to ourselves. We have -3 times -3, which is positive 9. We have -3 times -3 again, which is positive 9. And positive 9 times positive 9 is positive 81. Okay, so that is exponential notation. Hopefully it was a decent review, but really focus on understanding what happens when you multiply a series of negatives or a series of numbers involving positives and negatives, and understand the difference between exponential notation where you have a negative base that is in parentheses versus not in parentheses. Okay, not in parentheses, always negative. In parentheses, even exponent, positive, odd exponent, negative. Okay, so make sure you get some practice with this, and then next time we'll look at order of operations.